welcome all the uh, attendees to the World Potato Congress webinar series. My name is David Douchis. I'm at Michigan State University. And also here with me is Ms. Jan Fierro, who is our communications manager on our USAID project. And you'll have a chance to hear from Jan during the webinar. And so as you can see right now on the screen here, you have your little advertisement for the World Potato Congress in Ireland for 2021. And it looks like a beautiful place to go. So maybe you might want to consider that. So today, my talk is titled Durable Late Blight Resistance to Southeast Asia, Feed the Future Biotechnology Potato Partnership. And so this project is a USAID funded project under the Feed the Future program. And we're referred to as the Biotechnology Potato Partnership. And USAID has a component of their program where they're looking for science-based answers to sustaining farmers, solving hunger, and securing our planet. And Michigan State University has been funded now for 4 years and on this project to develop biotech late blight resistant potatoes for Southeast Asia. Our partners are University of Minnesota, University of Idaho, and in the private sector, it's Simplot Plant Sciences. And you'll learn about this in our webinar today. And so just to start it off, we all know that potatoes feed the hungry. It's really one of our best crops because it produces a nutritious food crop more quickly on less land in harsher climates than any other crop. And so if we're going to be dealing with hunger around the world, potatoes is a great crop to consider for this. And the United Nations is well aware of this effort. And so potatoes are grown all around the world, and our target countries for this project are Indonesia, which ranks 40th in potato production, but I believe ranks 4th in world population. And so if you can see my arrow, you can see Indonesia for people that aren't familiar. And then our other target country is Bangladesh. And Bangladesh, I think is surprising because it's 7th in world potato production, and it's just a small country. And this country is the size of the state of Michigan, where I live. And Michigan in the United States has 10 million people. Bangladesh has 165 million people. So they have a lot of people that need to be fed. And so USAID feels that this is a very important country to target for food security. The problem with potatoes in Bangladesh and in Indonesia is the potato late blight disease. It's worldwide, it's the most economically important disease of the potatoes, costing billions of dollars. Worldwide, there's crop losses of 15 to 30%, despite all the farmers' efforts to protect the crop growing around the world. And this great figure here shows potato production where potato production is around the world and the severity of late blight in those regions. And in Bangladesh and Indonesia, late blight is a consistent problem requiring anywhere from 5 to 12 sprays per season to control or maintain some level of control of the pathogen. And so, as I mentioned, Bangladesh is our target country. It's characterized by having smallholder farmers. There's a high cost of inputs based upon their budgets, and there's limited cold storage facilities. So much of the crop is consumed in the first few months after harvest. Besides late blight, there's other crop damage by other insect pests and diseases. And because of of all these pests, there's a reduction of yield in the field, and also that carries over into the storage. I also want to point out that in this slide, you can see a farmer spraying his field. In this case, he was spraying his fungicide. And I think that this, to me, is a very critical point to make, is that the farmers in these countries are doing everything manual, and they're spraying their fields and putting a lot of health risk on themselves to maintain their crop. And something that in the United States we don't really think about very often is that personal protection equipment that is maybe not available in these developing countries. Indonesia, similar to Bangladesh, has smallholder farmers, high costs of inputs. It's actually the largest potato producer in that part of the world, and potatoes are grown in the mountains and maybe in some of those terrace locations, and they have very high late blight disease pressure. We see infections starting at the time of the potato's emergence because of their tropical climate. The disease is available year round. So the goal of our USAID project is to bring durable late blight resistant potato varieties to smallholder farmers in Bangladesh and Indonesia. And what we're trying to do is leverage the partnerships between the private and public sector so that we can very efficiently create commercial level biotech products. In addition to that technical aspects, we really want to strengthen the in-country modern biotechnology research and testing, working on the areas of technology transfer, deregulation, commercialization. We also want to build human and institutional capacity. I think that's really important to USAID, is that the scientists in the country have the capacity to continue this work as we move past the project. Also, biotech education, communications, outreach is important, and as Jan will bring that forward a little later. And then what's also important is those cross-cutting themes of really considering the environment, gender equity, and other socioeconomic components that are involved in agriculture. Taking a moment to talk about the science. So what we're talking about are GM potatoes. And traditionally, plant improvement has been done through plant breeding, where we would take a wild species that may have a resistance gene, cross that to our cultivated potato, and we could introgress that resistance gene, but we bring along a lot of undesirable traits that may be associated with that wild species. With the GM technology, the genes are cloned, and then that cloned gene is inserted into the plant via some transformation system, in our case, agrobacterium. And so only the resistance gene is transferred and none of the undesirable characteristics. And I think that this strategy is really important in our target countries and even in other places, because in potato production, what's very important to the farmers and to the consumers is the variety that is grown and sold. You can't just simply replace potato varieties in many of these countries. There's market demands, and so we're able to take the farmer preferred, consumer preferred varieties and transform them with these resistance genes. And so the process of genetic engineering for potato is well known. For us, it's a 3 to 6 month process if we have the construct in place and everything goes well, that the variety is amenable to transformation. And so we can go from the laboratory to the field, in a 1 to 2 years, depending on how the process goes. So what makes this project very exciting is that we have available to us a lot of late blight resistance genes, which we refer to as R genes. And so these R genes are been identified in the wild species of potato, which come from Central and South America. And a database of these R genes exists. And most of these genes have been cloned by the University of, or Wageningen University, and also by the Sainsbury lab in the UK. And so these are available to create late blight resistant potatoes. Again, a little bit more science. We have the resistance gene. So what we're trying to do is create a 3R gene late blight resistant potato. And so these R genes that I'm talking about are in many of the wild species. And what they do, these R genes do, is they recognize the protein or effector that's secreted by the pathogen Phytophthora infestans. And so if the R gene can recognize that the pathogen is there, it turns on the plant defenses and protects the plant from Phytophthora. The pathogen can actually evolve to overcome the pathogen, overcome the host plant resistance at time, or the R genes. And so it's really best if we stack a set of R genes in potato. And so we have like over 20 R genes to work with at this time. And there's probably many more that are going to be discovered. So let's just look at this process. So if we have one R gene and we are to test that against a series of late blight isolates from around the world, you can see that there's a variation in how the plants held up to the pathogen. If we look at transform the plant with another R gene, again, we see a different array of resistance patterns. So if we actually stack 3 R genes into the single plant, all the plants are resistant to all the isolates, and this has been our goal, is to create these 3R gene potatoes. And so our partner on this project is Simplot Plant Sciences. They've been able to obtain the intellectual property rights to work with a set of R genes. The ones that we are transforming into our preferred varieties are VNT1, MCQ1, BLB1. They all come from Solanum wild species, native genes. They've been cloned into a single vector construct, which are then transformed into the potato. Okay, so what I'm going to take a few minutes is to walk through kind of our technical plan. The first is the proof of concept, then the product development, the evaluation and testing of the material, and then when that's all, we're up to the point of the evaluation testing, and then what we'll be doing is move into our second 5-year plan, which is really moving towards the collection of the data and regulatory data that can be used in getting the approval in country and commercialization of those potatoes. So at Michigan State, we did some transformations with a 3R gene construct and grew those plants out in the field. And if you look at this picture here, you can see 4 rows of green plants, and you have two rows of dead plants on each side. So what we're seeing is those dead plants are the Atlantic border rows that is susceptible to late blight. And then in the 4 green rows, you see many of our 3R gene potatoes. If you look closely, the Atlantics are completely dead. We also had a single R gene construct out there and had partial resistance, but really did not provide strong enough resistance to the US 23 isolate that we were testing in that year. Whereas our 3R gene potatoes were healthy green. We did not see any lesions on them in that field season. It was quite impressive to experience that firsthand. And I mentioned that we've been working with Simplot Plant Sciences. They're a great private sector partner. They have advanced R&D capacity. They're really the 3rd largest potato research center in the world, and they've got a cutting edge plant pathology lab. And so they're well versed in tissue culture, the technology, the pathology, and actually releasing products. They have gone through the process of deregulating and commercially releasing genetically modified potatoes, and they are being grown and consumed in the US. and they also have the stewardship experience. And so having Simplot on board really increases our efficiency to get the work done, and also increases our opportunity to be highly successful with this project. And so the Simplot advantage is the resources that they can put behind things. And so they started with over 30,000 potato explants for transformation. That's an enormous number. That's probably, 20-fold more than I would expect to see in a public sector project of this nature. And so they were able to really mobilize a large amount of resources to get this done. And so then they obtained events and then did the molecular characterization to look at copy number, that there's the intact genes are transferred, and that also there's no backbone. And so they have 130 events for the granola that pass through this process. So we have an enormous number of events to choose from that will for the pathology testing, and then ultimately for the agronomic testing. And so they took these 130 granola events and tested them across a series of late blight strains, and what that allowed them to do is to evaluate the functionality of each of these R genes, so that we have a very systematic, strong understanding of the genes in the construct, that they're working, and so we can kind of have confidence in the durability of this 3R gene events that we have. And so we have Simplot then has passed through to us their 10 best 3R gene diamonds. We were able to do some further molecular characterization, take them to the field in 2019, and now we've been able to put them into our certified seed production so that we can take those mini tubers to our target countries. The same for granola. We've gotten their events. We've started seed production on them, and we started the molecular characterization. And so we're in a position to take this material to Indonesia in 2020. And so the molecular characterization really involves some genomic walking and also sequencing to know whether we have an interruption of the genes at the insertion or whether there's any genomic deletions at the insertion site. And so of the 10 events that we've obtained, we have confidence that there's 5 diamond events and 6 granola events, that there's no gene interruption. And so from there, we're choosing the 2 events that can that we'll take to the countries. What's really important to this project, besides the developing the biotech products, is having the pathology partnership. And Dr. Phil Wharton from the University of Idaho is our plant pathologist on the project. And he's been going to these target countries and working with the pathologists in those countries to obtain isolates and genotype those isolates so we know what the pathogen diversity is in that country. Phil's been presenting results of this work at various conferences, and I'm not going to go into any of the details, but we do know that these isolates from the Indonesia and Bangladesh, some of them do derive from Europe, that must have come over in some manner, and but having this knowledge is important for us to test the material in the country. Also, what's been important is the capacity building. We've had the scientists from Bangladesh and Indonesia spend time at Michigan State University in getting some technical and regulatory training. And the leader of our regulatory training is Dr. Karen Hokanson from the University of Minnesota. And so she really leads this effort and travels to the countries and spending time with the teams, building up their capacity in the regulatory area. And so what this has resulted in is developing what we call the capacity evaluation manual. And so this was actually done in partnership with the scientists in the country. So we have country-specific standard operating procedures that are used. So we've been able to go in country and kind of evaluate laboratory safety, tissue culture handling, greenhouse mini tuber production, molecular identification, and plant and pathology testing. And then this is kind of culminated in 2019, what we refer to as our mock confined field trial. And so what's very important to us is the stewardship. So if we're going to bring biotech products into a country, we want to make sure that they're handled in the right manner. And so they developed their in-country standard operating procedures. So now we did is we pretended that we brought a biotech potato to the country, went through the process of planting that trial, collecting data, harvesting that trial, and seeing how our standard operating procedures work. And that allowed us to find little weak links in that process and then correct those. And so the mock trial in Indonesia was harvested last February, and in Bangladesh it was last March. And so so now we're in a position to bring our potatoes to the country. I have seed here at Michigan State that is going to be imported to Indonesia. It says January 2020. We're waiting for our import permit, and then we'll be bringing the granolas for a March planting. So we're going to have 2 confined field trials in Indonesia in early 2020, and in Bangladesh we're scheduled for a November 2020 planting, since Bangladesh only plants in the winter months. November's their target planting month. So whereas Indonesia, there's kind of a continuous cropping, so it gives us more flexibility in getting the material into the country. And so we have all the experimental designs laid out. The teams in country have been, have that experience of working with this already through the mock trial. So we're quite excited to move forward at this time. And so where are we in this whole process? So if you really look at a biotech idea, it takes 10 to 15 years to get that idea out and launched. And so where are we? And so if you look at this, you can see we're in the column E, where we're in advanced testing, and we'll start the process of collecting data in country so that we can move towards developing a regulatory dossier. And so at this time, I'm going to turn the webinar over to Ms. Jan Fierro, our communications manager. And welcome, Jan.
Thank you, Dave. One thing that our project acknowledges is that communications activities are a very important component for the success of the project goal, which really goes all the way through commercialization and scaling of the late blight-resistant potato. So we need to ensure that we have acceptance of our product across all stakeholders at every point in our value chain. So this will start with our farmer and go through all the way to the end user consumer, and not just in a rural setting, but also with urban dwellers in these developing countries who are using more conventional market systems like grocery stores and supermarkets, and not necessarily just in a rural market setting. So our project is taking a complete life cycle approach, not just the research, when we're considering our communication strategy. So our strategy that we developed really is based on 5 components. The first is that we are proactively communicating the technology and its benefits, as we are passively monitoring the anti-movement activity in an effort to promote a transparent and fact-based message that is personalized to each audience with specific framing that will address each audience's needs, while we partner with biotech allies to gain consistency and amplification of our efforts. So this strategy has driven the following message. The combined challenges of increased world population and global climate change make it critical that we develop and utilize the best possible combinations of technologies to feed future generations. Genetic engineering is one technology that responsibly increases the productivity and the economic standing of smallholder farmers while reducing inputs and environmental impacts. To simply kind of clarify that down to one sentence, our message really is that the late blight resistant potato is a safe food product that benefits the environment and the community. So one of our biggest challenges in communicating biotech is that it's a complex scientific process that has come across a lot of controversy. So the way that we look at this and the way that we want to communicate it in a manner that meets the expectations of our audience is we really look at our communications through building of a complete network. And when I say complete network, we're talking about advocating. There's a great network of biotech advocacy organizations globally. And so we partner with all of them, which we actively are doing in our partner countries and in the US. We also are hoping to continue to build collaborations and partnerships with industries. Universities in our target countries offer us a great opportunity to connect with youth. We work in our countries through US government affiliations with USDA Foreign Ag Service and our USA country missions to help collaborate in-country efforts, and then also working with other GE crops, be it BT brinjal, which was very successful in Bangladesh, golden rice, and a lot of the other crops, because together we can build a consistent and cohesive message that will resonate against and across all of our stakeholders. So biotech really, one of the things that we're really hoping is that through this whole process, we see people and leaders who will rise to positions of what we will call our biotech champions. And I just wanted to end, one of our biotech champions was, or is, the ex-Minister of Agriculture in Bangladesh, Matia Chowdhury. And I just wanted to leave you with this great quote, which I think will help foster biotech and its adoption across the world globally. And she says, "We will be guided by the science-based information, not by the non-scientific whispering of a section of people. As human beings, it is our moral obligation that all people in our country should get food and not go to bed on an empty stomach. Biotechnology can play an important role in this effect." So I'm going to turn it back over to Dave, and he's going to wrap up a little bit about the project.
Thank you, Jan. As you can see, we feel this project is quite important. We think we have a great product. And so where are we at this time? We've strengthened the modern biotechnology, R&D, technology transfer, commercialization, and so on in these target countries of Indonesia and Bangladesh. We have the 3R-gene product, and it's now in the advanced stage. We're bringing them to the countries. I think the speed at which we've been able to achieve that, we have to pat our private sector partners on the back there. We've been able to build the human and institutional capacities, and we'll continue to do that in country because it's an ever-changing biotechnology, biosafety, and regulatory that we face. And we're going to continue to do our cross-cutting themes of the environment, gender, and other socioeconomic components. And we now have a network of 17 global institutions in 5 countries. And just to finish up, I want to show our Indonesian team here, which is we're working with EcoBiograd and also with IBEGRI. That's where our scientific team is. And in Bangladesh, our scientific team is at the Bangladesh Agricultural Research Institute, or BARI, and at the Tuber Crops Research Center, TCRC. And also our own team, our at Michigan State University, who a number of our people been named during the talk, as well as our plant science, Simplot Plant Sciences team, great group of scientists there to work with. And so at this time, I'd like to just say thank you, and I appreciate your attention on the talk here. And I think I will stop sharing the screen so I can take questions. So Nora, are you in a, do you have the questions for us at this time? Okay. If a country, so the first question I have here is, if a country wanted to establish a program like this, how would they go about establishing this? Okay, so USAID funds a number of these biotech projects around the world. They have a set of target countries that they feel are the most vulnerable in terms of food security. Bangladesh is one of those countries. So I think that if you're in country, in one of these countries, maybe you need to work with your government to work with the USAID, and if there's a mission office in your country to see if you can bring that to their attention. Okay. Another question here is, can you say a word about durability of resistance? Okay, so that's a tough one to say. So the scientific literature, in my understanding, has shown that if we stack 3 R genes together, that it's quite difficult for the Phytophthora infestans pathogen during the field season to evolve and overcome the resistance. So we've tried to design our 3 R gene construct to have as a broad level of resistance to to a set of pathogens that we've been able to collect from around the world. So there's no guarantee in the biological world that these plants will maintain resistance, but we do feel that under our current conditions, that the durability will be much greater than in a single or double gene construct. But also, which comes into play, is that late blight can be also partially managed by some protectant fungicides. So maybe playing into the broader picture, that it's not a complete loss of fungicides, but actually using the host plant resistance in conjunction with a much reduced fungicide management system might increase the durability. Okay. I'm not seeing any other questions at this time. There are one Q&A. Okay, hold on. Sorry, Nora. Okay. In Bangladesh, BT eggplant is accepted. Will the potato follow easily? So that's a great question. The acceptance of the BT eggplant by the farmers has been phenomenal. I think it's quite clear that is a clear advantage to the farmers and the consumers by significantly reducing the amount of pesticides used on the eggplant. The next crop to be commercialized, biotech crop to be commercialized in Bangladesh, is supposed to be golden rice, and that's up for in the regulatory review right now, and we expect to hear positive knowledge on that area. So we're confident that our potatoes should follow behind if we do a good job of putting together the regulatory dossier and showing that we do have a safe product for the farmers and the consumers in Bangladesh.
And in speaking with the farmers while visiting country, they do share a lot of concerns that the fungicide cost really accounts for a large percentage of their input costs. And I think having the BT Brinjal there in having that proof of concept that the technology is sound will definitely help in furthering the acceptance of the farmers. The farmers seem to be very excited about the prospect. You know, a lot of the ones that we've interacted with as having positive feedback from their families, and that they see this as a real strong something that's going to really directly impact their livelihood moving forward.
Okay, and so we have another question here. You mentioned 3 R genes. Are there others in the pipeline to ensure that there is a backup if the pathogen overcomes these? There are many clones of Blight with greater than 3 virulences. Yes, good tough question there. And so there are other genes available, and I expect more to come along. And you know, talking with our partners in at Simplot, they do have other genes that they think would be quite valuable to use, that have you know, a great level of resistance to a number of the isolates that they've been testing. So it's not trivial to replace the potatoes, but I think that work could be done to create additional 3R gene potatoes. Okay, why do you call your potatoes GM? You are moving genes from potatoes to potatoes, not so for eggplant or the golden rice. So that's a good point. That so some people would refer to this technology as rather than transgenic, but say that it's cisgenic or intergenic, and that we're using native genes to be expressed in the potato. And so yeah, so this is really showing the advances in GM technology, that from using foreign genes to using actually genes from the relatives of the potato to create improved potatoes. Thank you.
Yeah, one other thing on that is I think for us, it speaks to our commitment to transparency, and especially in our messaging, in that, you know, we don't want to leave a door closed potentially or open for someone to say, yes, it's potato to potato. There still is a process of intervention that's happening that we just want to be transparent about.
Okay, the next question I have here is, one of the challenges we are now facing, more so in the near future, what are your thoughts on how can biotechnology make the potato crop more climate resilient? So I think there's a lot of great opportunities through biotech that they're to make the potatoes more resistant to other biotic stresses and abiotic stresses that they're facing. It's a matter of having the resources to transform these genes into the target varieties for these countries. So I guess what I'm really hoping is that this USAID project demonstrates that we can create biotech projects that are helping people, and it opens doors for other biotech products to come down the line, because there's great opportunities with biotechnology to improve the potato. And I myself am a potato breeder, and so I kind of feel that between improved varieties and stacking and being able to further improve some of those varieties with biotech tools is really the best strategy. We need to overcome some of these fears of the GM technology. It's been around commercially since the mid-90s. I think we have a lot of proof now that this technology can help solve some of the problems that we face. Okay, so I'd like to thank all the attendees for hanging on and for the webinar, and I hope that you enjoyed hearing about our project. And if you have any further questions, you could always track me down by email. Thank you.